First, on a sketch of Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities. The modulus of z minus 4 minus 2i is less than 3, and the modulus of z is greater than the modulus of 10 minus z. So for the left locus, this is a circle because we have z on one side only. To find the center, make it in the z minus z1 form. Notice that if you open up the brackets, you should get the original minus 4 minus 2i. So now we can see the center is 4, 2, and the radius is 3, and smaller than means we shade inside the circle. So this is the center of the circle, the radius is 3, so this is the sketch. And now for the second locus, we have z on both sides, so this is perpendicular bisector. To identify the points, make it z minus z1 form. Because there's nothing here, it's just 0, 0. And here, it's, first of all, this is actually the modulus of z minus 10. Exactly the same thing. So, we make it z minus 10. Alright, so the points are 0, 0 and 10, 0. And we shade towards the side with the smaller side, so we shade towards 10, 0. So to draw the perpendicular bisector, label the 0, 0 and the 10, 0. Connect the 2 points, so this is the line connecting the 2 points. The perpendicular bisector is supposed to be perpendicular to that line, perpendicular, and also bisecting in the middle. So that's why we have this line vertical through x equals 5 in the middle, and we shade towards the 10, 0. Now if we combine the two graphs, the intersection would be, you have to draw the circle and the perpendicular bisector, shade inside the circle and to the right of the perpendicular bisector. So we need to label the center of the circle, we need to label the x-intercept of the perpendicular bisector, shade the right region, and make sure the radius is around here, because the radius is 3, so this is the sketch. Okay, next part, find the greatest value of arc z for points in this region. So first of all, z is, so the z is a point from the origin to any point here in the shaded part. So z can be this line from origin to around this point or around this point to any point in the shaded area, that is z. Now argument of z is the angle from positive real axis to z. So the angle starts from around here, which is negative angle, and so on. This is positive angle because we are finding the greatest. They'll be around here. So this is the greatest argument z. Okay, so to find this angle, I'm redrawing this triangle here. So if you look at the triangle, we already know this is 5, this is 5, we already know that. And now we don't have this side here. If we have this side, we can use inverse tangent, we can find theta. Problem is we don't have the length here. Okay, so this length we don't know yet. So how do we find that length? So I'm redrawing the yellow triangle over here. So first of all, we know that this is the center of the circle, this is the circumference, so this length must be 3. And now we know that this value from here to here, this length is obviously the same as this, so that'll be 2. So this length is 2. And now we already know also that this is 4, this is 5, so this length here is supposed to be 1, so that's why this is 1, so this is 1. Now we know this is 1, this is 3, it's a right angle triangle. Use Pythagoras, we can find this length. So square root of 3 squared minus 1 squared, root 8. That's why we have root 8 here. So that means the total length is 2 plus root 8. That's why it's 2 plus root 8 for this length. Now we can use tangent. Tangent theta is opposite over adjacent, and then use inverse tangent. We get the answer if you use radians, 0.768. Alright, I'll see you again next time.